In 1963, a young mechanic from Malvern, Pennsylvania, walked into a Pontiac dealership and asked to see their fastest car. The salesman pointed him toward a white coupe sitting in the corner of the lot. It had a 421 cubic inch engine, aluminum exhaust headers, and a reputation for being almost impossible to tune properly. Most mechanics took one look under the hood and walked away. Bill Jenkins bought it on the spot. This is the story of how one man discovered the secrets that made Pontiac's Superduty engine unbeatable, and how his work proved something that the entire racing world had gotten wrong. For decades, the conventional wisdom was simple. If you wanted to go faster, you needed more displacement, more cubic inches, more raw power. Jenkins was about to show everyone that tuning beat displacement, every single time. Along the way, we're going to see factory-backed drag racing programs, engineering secrets that Pontiac never intended anyone to find, and a rivalry between engine builders that pushed American muscle cars to their absolute limits. So let's begin. But first, what exactly was the Pontiac Superduty, and why was it so difficult to make it run right? Now, to understand what Jenkins accomplished, you need to understand what he was working with. The Pontiac 421 Superduty wasn't just another big block V8. It was, in many ways, the most advanced production-based racing engine General Motors had ever built. And I use the term production-based loosely because these things were barely street legal. The Superduty program started in 1959, when Pontiac's engineering department decided they wanted to go racing. Not just weekend warrior stuff. Real sanctioned drag racing and NASCAR competition. The problem was that General Motors had officially banned factory involvement in motorsports back in 1957. The Automobile Manufacturers Association had gotten together and agreed that none of them would participate in racing or use racing in their advertising. It was supposed to calm down the horsepower wars that were making insurance companies nervous. Pontiac's response to this ban was, essentially, to ignore it completely while pretending to comply. They couldn't officially support racing teams, fine. But there was nothing stopping them from developing special parts and making them available through their dealer network as service replacement items. If a customer happened to use those parts for racing, well, that was the customer's business. The 421 cubic inch displacement came from boring out Pontiac's existing 405 block and increasing the stroke. By 1963, the engine was producing somewhere north of 400 horsepower in street trim. The factory rating, anyway. The real number was probably closer to 460 or 470. Pontiac was playing games with the advertised figures to keep the insurance companies and the corporate brass at General Motors from asking too many questions. But here's the thing about the Superduty. The parts were exotic for the time, forged pistons, a solid lifter camshaft with aggressive timing, aluminum exhaust manifolds to save weight, huge 4-barrel carburetors. On paper, it was a masterpiece of early 60s performance engineering. In practice, the thing was a nightmare to tune. See, Pontiac's engineers had designed the Superduty for maximum peak horsepower. They wanted big numbers for the brochures and the spec sheets. What they didn't optimize for was drivability or consistency or the kind of precise tuning that actually wins drag races. The carburetor jetting was wrong from the factory. The ignition timing was a compromise between too many competing priorities. The valve springs were barely adequate for the RPM range the engine could actually achieve. Most guys who bought Superduty Pontiacs in 1963 had no idea what they were sitting on. They'd take the car to the drag strip, run a few passes, and wonder why they were getting beaten by supposedly slower machinery. The engine had the potential. It just needed someone who understood how to unlock it. Enter Bill Jenkins. Jenkins wasn't famous yet in 1963. He was just a talented mechanic with an engineering degree from Cornell and an obsession with making things go faster. He'd been racing for a few years, learning the hard way what worked and what didn't. By the time he got his hands on that white Pontiac, He'd developed a methodology that set him apart from almost everyone else in the sport. Most drag racers approached tuning the way you'd approach cooking without a recipe. They'd change something, make a pass, see if the time improved, and then change something else. It was intuition and trial and error, and it worked well enough for most people. Jenkins approached it like a scientist. He kept meticulous records of every modification, every pass, every weather condition. He measured things that other racers didn't even think to measure. He wanted to understand not just what worked, but why it worked, and he had the engineering background to actually figure it out. The first thing Jenkins noticed about his Superduty was that the carburetor was running way too rich at wide-open throttle. This was pretty common knowledge among serious racers, but what most guys did was simply lean out the main jets and call it a day. Jenkins went deeper. He realized that the problem wasn't just the jetting. It was the entire fuel delivery system. The 421 had enormous intake ports. Really enormous. Pontiac had designed them to flow as much air as possible at high RPM. But at lower speeds, that massive port volume actually hurt performance. The fuel would fall out of suspension in the intake tract, puddle on the floor of the ports, and create inconsistent mixture distribution between cylinders. I mention this because it explains something that had been puzzling racers for years. Superduty Pontiacs were inconsistent. You'd make one pass and run a great time. The next pass, with seemingly identical conditions, you'd be 0.2 slower. Nobody could figure out why. Jenkins figured out why. The inconsistency was coming from uneven fuel distribution. Some cylinders were running rich, others lean, and the balance changed from pass to pass, depending on factors nobody was controlling for: engine temperature, fuel temperature, how long the car sat at the starting line before the green light. His solution was elegant. He modified the intake manifold to improve fuel atomization and distribution. He changed the carburetor spacer. He experimented with different fuel line routing to control fuel temperature. These weren't dramatic changes. They were subtle refinements that most people would never think to try. The results were immediate. His elapsed times became consistent. Pass after pass, the car ran within hundredths of a second of the same number. That consistency gave him something almost none of his competitors had: predictability. He knew exactly what his car would do, which meant he could dial in his reaction times and his shift points with precision. But Jenkins was just getting started. If you've made it this far, you're probably into this kind of stuff. Quick question: where are you watching from? Drop it in the comments. And hey, subscribe if you haven't. We do this every week. All right, back to Jenkins. Because his next discovery was even more significant. The Superduty's ignition system was, frankly, inadequate for what the engine could do. Pontiac had spec'd a standard points and condenser distributor with a vacuum advance mechanism. The vacuum advance was completely useless for drag racing, and most people disconnected it. But the mechanical advance curve was also wrong. Jenkins spent weeks on his distributor, testing different spring tensions and advance limit settings. What he found was surprising. The factory timing was actually too aggressive at low RPM and not aggressive enough at high RPM. The engine wanted more initial timing than Pontiac recommended, but a slower rate of advance as the RPM climbed. Getting this wrong by even 2 or 3 degrees could cost you 1/10 of a second in the quarter mile. Now 1/10 of a second might not sound like much, but in drag racing, 1/10 is an eternity. Races are won and lost by hundredths. Jenkins was finding tenths everywhere he looked, just by paying attention to details everyone else was ignoring. The valve springs were another revelation. The Superduty came with springs rated for about 6,000 RPM. The engine could actually rev past 7,000 if you were brave enough to try. Most racers assumed that meant you needed stiffer springs to prevent valve float at high RPM. They'd install heavy-duty springs and pat themselves on the back. Jenkins tested this assumption. He discovered that the heavier springs were actually hurting performance. Yes, they prevented valve float, but they also increased friction and parasitic losses throughout the valve train. The engine was working harder just to open and close the valves. What Jenkins found was that a carefully matched spring rate with just enough tension to control the valves at his actual operating RPM gave better results than the heavy-duty setup everyone else was running. Think about that for a second. The conventional wisdom said stiffer is better. Jenkins proved that matched is better. The right spring, not the strongest spring. This became his philosophy. Don't assume bigger or stronger or more is the answer. Test everything. Measure everything. Find the optimum. By mid-1963, Jenkins was running elapsed times that nobody could touch in the superstock class. His white Pontiac became famous on the East Coast drag racing circuit. Other racers would show up with theoretically identical cars, sometimes with even more modifications, and Jenkins would beat them by multiple car lengths. The whispers started. People assumed he was cheating somehow, running illegal parts, secret factory support, something, because there was no way a privateer with a stock-looking Pontiac should be that fast. Jenkins wasn't cheating, he was just paying attention to things everyone else overlooked. Word got back to Pontiac's engineering department about this guy in Pennsylvania who had figured out their engine better than they had. This was embarrassing and fascinating in equal measure. A few of the Pontiac engineers started making discreet phone calls, asking what Jenkins had changed, trying to understand what they had missed. What they learned fundamentally changed how Pontiac approached the Superduty program for 1964. Several of Jenkins' modifications were quietly incorporated into the updated engine package. The carburetor jetting was revised. The distributor curve was changed. The valve spring specifications were updated. Pontiac never officially acknowledged Jenkins' contribution, but the engineers knew, and Jenkins knew they knew. But here's where the story gets really interesting. While Jenkins was dominating with his Superduty, the landscape of drag racing was changing. The AMA's ban on factory racing involvement was becoming a joke. Everyone knew the manufacturers were secretly supporting teams. Ford was pouring money into their racing programs. Chrysler was doing the same. General Motors corporate still maintained the fiction of compliance, but the division managers were finding creative ways around the restrictions. In 1963, Chevrolet released the Z11 package for the Impala. It was a 427 cubic inch big block that made even the Superduty look tame. The displacement war had begun in earnest. Cubic inches were the new currency, and everyone was scrambling to build bigger engines. Jenkins watched this happening and came to a different conclusion than most of his competitors. Everyone was chasing displacement. Jenkins decided to chase efficiency. His reasoning was mathematical. There's a limit to how big you can make an engine and still have it fit in a production car's engine bay. There's a limit to how much fuel and air you can physically move through a cylinder in a given amount of time, but there's almost no limit to how efficiently you can extract power from a given displacement. The guys building 450 and 500 cubic inch monsters were hitting diminishing returns. Each additional cubic inch produced less additional horsepower than the one before. But improvements in volumetric efficiency, in combustion efficiency, in reducing parasitic losses, those gains stacked. They didn't diminish. Jenkins kept his 421 while everyone else was boring and stroking to bigger displacements. He focused on making every cubic inch work harder. Better cylinder head porting to improve airflow, refined combustion chamber shapes to promote more complete burning, precisely matched components to reduce internal friction. The results spoke for themselves. By late 1963, his naturally aspirated 421 was running times that guys with engines 50 or 60 cubic inches larger couldn't match. The racing world was paying attention now. There's a famous story from this period that perfectly illustrates Jenkins' approach. A competitor came up to him at a race and asked what his secret was. Jenkins smiled and said something along the lines of, "There's no secret. I just measure everything." The other guy didn't believe him. How could measuring things make that much difference? Jenkins offered to prove it. He took the guy through his entire preparation process, the way he checked every valve lash with a feeler gauge, and adjusted them to within 0.005 of an inch of his target spec. The way he verified ignition timing with a degree wheel rather than just eyeballing the timing marks. The way he weighed his fuel and oil charges rather than estimating volumes. None of these individual items was revolutionary. Anyone could do any one of them. But Jenkins did all of them consistently, every time. The cumulative effect was an engine that was optimized in 100 small ways that added up to a significant advantage. The competitor walked away shaking his head. He later told someone that listening to Jenkins was both the most valuable and most discouraging 30 minutes of his racing career. Valuable because he now understood what winning required. Discouraging because he knew he'd never have the discipline to actually do it. This is the thing about Jenkins that separated him from virtually everyone else in his era. He had the technical knowledge to understand what mattered. He had the discipline to execute consistently, and he had the patience to test, measure, document, and refine over hundreds of passes and thousands of hours. Other racers wanted the magic bullet. The one trick that would make them fast. Jenkins understood that there was no magic bullet. There were 1,000 tiny improvements, each one worth a few thousandths of a second, that together added up to winning. By 1964, Jenkins had become a legend in superstock racing. His white Pontiac, now updated to the 1964 body style, was virtually unbeatable. He'd won enough races that the other competitors knew they were racing for second place when Jenkins showed up. But the Superduty program was about to end. General Motors Corporate had finally had enough of the racing involvement that everyone knew about, but nobody was supposed to acknowledge. In January 1963, they issued a new, stricter ban on performance activities. Pontiac was ordered to shut down the Superduty program immediately. The 1963 model year Superduties that had already been built were allowed to be sold, but no more would be produced. The exotic parts that had been flowing through the dealer network as service items were discontinued. Pontiac's official participation in racing was over. This hit the Pontiac racing community hard. The Superduty had been their weapon, their statement of engineering excellence. Now it was being taken away by corporate suits who didn't understand racing. Jenkins' response was characteristically pragmatic. He continued racing his Superduty for another year, extracting every last bit of performance the platform could offer. But he also started looking toward the future. If Pontiac wasn't going to provide factory support, he'd find another manufacturer who would. That turned out to be Chevrolet, or more specifically, the Chevy dealers who were willing to unofficially support racers running Chevrolet products. By 1965, Jenkins had switched to Chevrolet and was applying everything he'd learned from the Pontiac to Chevy's big block engines. The transition was seamless. Jenkins didn't have secret Pontiac parts or special factory support. What he had was knowledge, understanding of how engines worked at a fundamental level, and that knowledge transferred perfectly to a different manufacturer's products. Within a year, Jenkins was winning with Chevrolet the same way he'd won with Pontiac. The other racers who had assumed his success was due to some special relationship with the factory realized they'd been wrong. Jenkins was fast because Jenkins was smart, disciplined, and relentless. The lessons he learned from the 421 Superduty informed everything he did for the rest of his career. The importance of fuel distribution, the criticality of ignition timing precision, the value of consistency over peak performance. These principles applied to every engine he ever built. And what of the Pontiac Superduty itself? The 1962 and 1963 cars became instant collectibles. Racers who had them held onto them, knowing that no more would ever be built. The exotic engine components became nearly impossible to find. Within a few years, Superduties were being hoarded rather than raced, their value as collectibles exceeding their value as race cars. The irony wasn't lost on the people who had been involved in the program. General Motors had killed the Superduty to avoid the appearance of racing involvement. But the cars' premature cancellation made them legends. They became more famous, more valuable, and more sought after than they ever would have been if the program had continued for another decade. Jenkins went on to become one of the most successful drag racers in history. He won NHRA Pro Stock Championships in the 1970s. He built engines for other racers who dominated their classes. He became known as the Grump, a nickname that came from his serious demeanor at the track. But he always credited those early years with the Superduty as his formative period. That's where he developed his methodology. That's where he learned that tuning beat, displacement. That's where he discovered that the racer who paid attention to the small things would beat the racer with the bigger engine. The Pontiac 421 Superduty was not the biggest engine of its era. It was not the most powerful on paper, but in Bill Jenkins' hands, it was unbeatable. Because Jenkins understood something that most of his competitors never figured out. The engine is just potential. The tuner is what realizes that potential. And what of Jenkins himself? He continued racing and building engines well into the 1990s. He became a mentor to generations of younger racers who sought him out for advice. He was never one to give secrets away freely, but for those who showed the right attitude, the willingness to work and learn, he would share what he knew. He passed away in 2012, at the age of 82. The tributes that poured in from the racing community spoke to his influence. Champion after champion credited Jenkins with teaching them how to approach racing as a science rather than an art. His legacy lives on in every racer who keeps meticulous records, who tests rather than assumes, who understands that attention to detail beats brute force. The Superduty Pontiacs he made famous still exist, most of them in collections now, too valuable to race. Once in a while, one appears at a vintage event, and the old-timers gather around to tell stories about the white Pontiac that nobody could beat, about the quiet guy from Pennsylvania who figured out what everyone else missed, about the years when tuning really did beat displacement, and one man proved it pass after pass after pass. And that is the story of Bill Jenkins and the Pontiac Superduty. If you enjoyed this one, subscribe for more. Let me know in the comments, had you heard of Jenkins before this? Take care, and I'll see you in the next one.